Hello, everyone, and welcome to week 3 of Calculus 1, Calculus AB. This is going to be lesson 3, the derivative, probably the single most important lesson out of the entire 8-week course. And that's because we're going to be introducing some of the topics that you are going to be using basically from October to the end of the year, because this is going to be something we're using all the time as soon as we're done with limits. Anyways, we have lesson 3, the derivative, which means we have to talk about what is a derivative. And the very first thing we need to say is it's the slope. That's all a derivative is. It's slope. It's the slope anywhere on a graph. You can also say it's an instantaneous rate of change, and we'll talk about that more later. But for right now, I just want you to think of a derivative as the slope. So we look at this function right here, and I would say a few things I know about the slope. For instance, I know the slope is negative right here because that's like a negative slope. So we can say a negative slope right there. We know it's a zero slope at that point right there. It's a zero slope. And you can say it's a positive slope, not just, you know, at this point right here, but you can say it's a positive slope over like a range of values, like anywhere until you get to the zero slope up there. All of these slopes are positive slopes. And you can probably tell that from the graph, but you're not always given a graph. Most of the time you're given a function. Like, I don't even know what function this is because I didn't write it down, but this is some function. And I'm going to tell you, you're going to be able to find the derivative of most basic functions by the end of this lesson, which is great for you. So first we need to talk about the derivative notation, because notation is always important. We have 3 different ways we can say the derivative. I'm going to give a bunch of examples before we get on with this, because it's super, super important you're familiar with the terminology, because if you're not, then I'm going to be saying words and they're not going to mean anything to you, and we don't want that to happen. So the first thing I'm going to say is f prime of x. This is the first one. It looks like f apostrophe x. Like, for instance, if this is f of x, we would say the derivative is f prime of x. The prime is the apostrophe, and we would say f prime of x. I'm going to say it over and over again so it gets stuck in your head. F prime of x. The next one we have is dy dx. And technically, I just want to say one thing. Technically, there's not one right answer. All 3 of these work. You can use them interchangeably. I'll show you some examples on the next page. But this is just another way of saying it. It's dy dx. Yes, it looks like it's a fraction, right? Looks like it's a fraction, but it's not. This is like one term. This is one term. This is one sentence. Dy dx. You do not say dy over dx. You do not say dy divided by dx. You literally just say dy dx, and that's the shorthand notation. And then the last way, this is the most formal way you can write the derivative, is you can say the derivative of the derivative with respect to x of f of x. And what this basically means is, you know what the square root symbol looks like, right? It's a square root. You know what a log looks like. It's that. Basically what we're saying is the derivative operator has its own notation. It's d dx. And when you take d dx of f of x, like I'm writing right here, it equals f prime of x, or I guess you wouldn't say dy dx, and the reason why is you only use dy dx for y, and I'll explain that in a minute. But basically, this is the derivative operator. Now let me give you a bunch of examples that will further your understanding. If you have a scrap sheet of paper, write it there. If you don't, you can find one later, I suppose, and write it down in the recording. But here's what I'm saying. If I have, for instance, the function y equals x, like the easiest example ever, then if I want to find the derivative, or the slope, I would call it this. I can call it y prime of x, or even just y prime, or I can call it dy dx. Both of these work. Now if I have the function f of x equals x, the same thing, I can call it one of 2 things. One, I can call it f prime of x like this. The other thing I can call it is df dx. And that's how that notation works. By the way, you'll notice a stark difference between y and f of x. You'll see that why is it called y prime and why is it called f prime of x? That's because y is special, and technically it's not even y. It's the difference in notation. See how I say f of x and see how this just says y? Well, if I don't say y of x, because I could have said y of x if I wanted to, if I say y of x equals x, which just looks confusing because you've never seen it written this way before, then it'd be y prime of x or dy dx, same thing. But typically you never see that for y. You can, there's nothing wrong about it, but usually you don't do it for y, you do it for every other letter like f of x, g of x, h of x, b of x, a of x. There's a bunch of different things. Another thing worth mentioning is that technically it doesn't have to be of x. Let me give you an example. I can say k of w equals w squared. This is confusing because you've never seen this before, but if I write f of x equals x squared, it's the exact same thing. And what that means is if I had f of x, I would write f prime of x, which means if I want to turn this k of w, two random letters I picked out, I would write k prime of w. And you very well can see this in calculus where they mix up the letters on you to try and trick you. Okay? But don't be afraid. Just remember that the first letter or symbol is the y variable, and the one in the parentheses is always your x. That's how you can remember that. Now we're going to continue with some examples and continuing the rules of derivatives, but this is just the first thing you need to know before we go forward because it is confusing. I know it's confusing. You might not understand it today. It's okay. The goal is to just get your feet wet with this stuff. So if you remember how we found derivatives the week before, we had this complicated equation right here using the limit definition of derivative. The good news is we will not have to use that for the rest of the six remaining weeks. Okay, we're going to be using the shortcuts, and we have eight shortcuts that we need to know for uncovering all of the derivatives, at least for just week 3. In week 4, next week, we're going to be covering the chain rule. And if you don't know what the chain rule is, good, because you shouldn't know what the chain rule is yet. But let's just go over some of the easy rules. That's what today's all about, the easy rules of derivatives. So the first one is the constant rule. What's a constant? It's just a number. There's no x next to it. So let me just show you a graph of what this function looks like. This is the function f of x equals 4. If I want to graph f of x equals 4, then that is literally just a horizontal line at 4 tick marks above. So there's y equals 4. Or I called it f of x equals 4. Basically the same thing. Now what I'm saying is, what's the slope of this line? The slope of the line is 0 everywhere, meaning when I say the constant rule, if you have a constant, the derivative is 0, f prime of x equals 0, and there you go. You just took your first derivative shortcut rule. Congratulations. Any questions so far on anything I said, including the stuff earlier? No? Okay, good. So the rule is if that's a number, like for instance, if I gave you f of x equals 12, or even 12,000, or even 12 million, then the derivative f prime of x is just 0. And yes, if I wanted to, I could have said df dx equals 0 as well. This is also correct. However, df dx is less common. You usually only use df dx with dy for dy dx. Okay, and I don't know why that is. That's just what I see in math. Next is the coefficient rule. Basically, if you have something in front of your x, then the answer is the number in front of the x. So in other words, I already know the derivative of this one. F prime of x is the number in front of the x, which means it's 2, and you're done. See how easy that is? And by the way, if you use the limit definition of derivative, in other words, the thing I crossed out up here, if you use this method's going to take you like 10 minutes to get the same answer too. So why would we ever use the limit definition of derivative? Only when they force us to, and it will say so in the question. Another thing worth mentioning about the coefficient rule, this looks exactly, to me, like the form y equals mx plus b, right? Because you got 2x, where that means m equals 2 and b equals 0, and you know that m equals 2 just means a slope of 2. And also, if you were to graph the function y equals 2x, it would look like a diagonal line like that with a slope of 2. Any questions so far on the first 2 rules? Okay, this is where things start to get interesting because next, number 3, we have the power rule. The power rule is probably the number one rule you're going to be using in calculus, and not just calculus. If you plan on being an engineer one day and you have some complex engineering classes that will require calculus, this is the number one rule they will like to use, the power rule. And here's what it says. If you have some function x to the n, basically x cubed, x to the fourth, x to the 100, x to some power, then what the derivative is, you take that exponent, the n, you put it out in front, and then you subtract 1 from the exponent. And I say where n is any real number, I mean that's just saying n can be basically anything that's not imaginary. What my calculus teacher always used to say is there's no I in calculus, meaning you don't have to worry about imaginary numbers, which is nice. What this also means is that n doesn't just have to be a whole number. N can be a negative number, n can be a fraction, n can be a decimal, n can be a square root. There's a lot of things n can be. Now let's do a super easy example, which is f of x equals x cubed. So for that one, when I have x cubed, I'm going to pull the 3 out in front, because that's what it says to do. Pull the 3 out in front and subtract 1 from your exponent. 3 minus 1 is 2. So the answer is 3x squared. Or you can say f prime of x equals 3x squared. And there's the answer. Any questions on that one? And don't worry, we'll be doing a ton of examples later on in the lesson. One more thing I want to say is sometimes you'll see something complicated. Like for instance, if you have a square root of x, this is what you need to do whenever you see square root of x in the problem. Rewrite it as x to the 1/2 power. The reason why is because a square root is really x to the 1/2 power. If you have a cube root of x, you have x to the 1/3 power, really. And so what that means for the derivative for both of these, the derivative for x to the 1/2, that's going to be 1/2 x to the, what's 1/2 minus 1? A lot of people struggle with this, believe it or not. And I'm just going to show you all because I need to show you for not for legal purposes because I don't think you're going to sue me, but I'm going to show you because some of you don't know. So basically, it's easy. You just need a common denominator. 1 can be rewritten as 2/2 like this. And basically the reason why that is you multiply 2 over 2 and you get 2/2. You're going to get negative 1/2. So that's the exponent. Going back to this page, it's 1/2 x to the negative 1/2 power, and there's your derivative. Same thing with the 1/3. Would anyone like to try this? Go ahead. No? Okay. It's 1/3 x, because I pulled the 1/3 out in front, times x, and then 1/3 minus 1. Remember, 1/3 minus 1 is the same thing as 1/3 minus 3/3. So you get negative 2/3 as your power. And that's what's going to go in the exponent for that. And then there's just one more thing I want to tell you as far as the power rule goes. This is like a special case of the power rule. It's if you have an x in the denominator, like if you have 1 over x. What you need to remember from algebra, probably algebra 2, is that this can be rewritten as x to the negative first power, and now you can use the power rule because you have a power. And the derivative of that would be pull the negative 1 out in front times x, and then what's negative 1 minus 1? It's going to be negative 2. So there's your answer, negative x to the negative second. Sometimes I see students write it like this, and this is correct as well. They'll write negative 1 over x squared. Both of these answers are correct, and the reason why is because what does a negative exponent mean in general? A negative exponent simply means you take the reciprocal of it. So for instance, if I have 1 over x to the negative 1, that's the same thing as x to the 1. If I have x to the negative third like this, then this would equal 1 over x cubed. Whenever you have a negative exponent, it just means take the reciprocal of it. And that's basically the power rule. You're definitely going to need to practice this if you want to master it. It's very complicated at first, but you'll notice it quickly becomes easy once you do it a few times. And with that, we move on to the trig derivatives. Basically, the trig derivatives, I'm just going to tell you, you have to memorize this. There's no getting out of it. You're not going to be a master of it today, but I'm going to help you with it today. And then for homework, I'm expecting you to have it memorized because we're going to be using it next week and the week after that. And if you don't have it memorized, well, then you're just kind of hosed and you can't do anything. So you definitely have to memorize these. Now, I'm just going to say them. I'm going to go through all six really quickly, and then we'll talk about some tips on how to remember them. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x, which are pretty close together. As a matter of fact, I'm going to group them together in their own little group because they're so similar. The derivative of tangent x is secant squared x. The derivative of cosecant x is negative cosecant x cotangent x. That's probably the most complicated one. Then you have the derivative of secant x being secant x tangent x. I'm going to group these together because they're kind of similar in their shape. Obviously, they switch secant with cosecant and tangent with cotangent, but they're kind of similar. And then the last one, cotangent x becomes negative cosecant squared x. Again, these are kind of similar in shape, so I'm going to group these together. And the last tip I'm going to give you for remembering is that any of the trig functions that begin with the letter C, for instance, cosine, cosecant, and cotangent, those are the ones that get the negative signs. And that is not a coincidence. I can't give a proof for why that is, but I'm going to tell you it's what it is. It's what you memorize. So any questions on the trig derivatives? Okay, great. Next, we have the probably the hardest rule of tonight. It's the product rule. Product rule itself isn't even that bad. What I notice with my students, they don't even know they need the product rule. And if you don't know if you need it, then how are you going to know to use it? So the number one thing you need to know today is how do you know when to use the product rule? It's simple. You have one function such as x times another function such as sine x, and you multiply them together. I know it sounds easy. I'll tell you what most of my students do wrong, and hopefully you will not make that mistake in the future. So with the product rule, basically you have u times v, where both u and v are functions of x. For instance, in this problem, I would say u is x and v is sine x. Notice I'm calling one u and the other v, and now I need to find u prime and v prime so I can plug it into this nice little formula right here. U prime times v plus v prime times u. So first let's find u prime of x. In other words, what's the derivative of x? The answer is, this is a coefficient rule, which was rule number 2 in our packet, which says you look at the number in front of the x, there is an invisible 1 in front of that x, so the derivative is just 1. Now for v prime. V prime, the derivative of sine x, you just have to memorize it. The answer is cosine x. And so now we just plug this in the formula. U prime times v, so that's 1 times sine x, plus v prime times u, which means cosine x times 1x, or you can just write x. And then you just simplify this, and you're going to get sine x plus x times cosine x. The order of how you write this doesn't really matter that much, so this is fine. Another thing worth mentioning with the product rule is that, see how it's u prime times v plus v prime times u? The good news is you can flip the order of this. In other words, you can say v prime times u plus u prime times v. It's the same thing. It's the same thing. The order doesn't matter. Okay? Now here's why this is going to be very confusing and why the product rule is terrible. The reason why is because the very next rule we have is the quotient rule, and the quotient rule, the order matters. Why does the order matter? Because see in the numerator how it's minus, it's not plus? That means the order matters. And so it's very important that you remember that for the quotient rule, and remember for the product rule, the order does not matter. So with the quotient rule, we just have to say, this time you have the numerator divided by the denominator. That means you have vu prime minus uv prime over v squared. And here's a little song I learned in Calc 1 to help memorize it. So here's the song. Low d high minus high d low over bottom squared, and off we go. And obviously you need to say the last part, and off we go, or else it doesn't rhyme. And how will you ever remember it if it doesn't rhyme? What this basically says, whenever I say the word low, that's v, that's the denominator, okay? And whenever I say high, that means u, the numerator. So when we say low d high, that's v, which is the low, times d high, d meaning derivative, okay? D high is the derivative of U, so U prime. And you can look at the song and see how it maps up to this. If you don't like the song, you don't have to memorize it. I don't care. But here's what we're going to do for sure. I'm going to say U is X, the numerator, and V is cosine X, the denominator. Then I need to say U prime, the derivative of X. We already did this, it's 1. And V prime, the derivative of cosine X, that's going to be negative sine X. Notice it's negative because C cosine begins with a C, so it gets the negative. And now we just have to plug in this formula. So V, which is cosine X, times U prime, which is 1, minus U, which is X, times V prime, which is negative sine X, divided by bottom squared. That means cosine X squared, like this. Or I'll simplify it in a different way in the next step. Basically what this simplifies to, numerator, cosine X. Double negative here means we get plus X times sine X, divided by cosine squared X, which is technically the better way to write cosine squared X. And that's our final answer. We're happy. One thing I will mention as a tip, typically after plugging in this formula, we will try and simplify the numerator as much as we can. And then also typically don't touch the denominator. Don't touch the denominator. I don't know why, but this is what we do. We just don't touch the denominator because basically it's already simplified as much as it can be. If you try and simplify it, you're probably going to make it more messy rather than cleaner. So, do we have any questions on any of this? Again, you're just going to have to memorize it. One more thing I do want to warn you, because realistically, when you take calculus in the fall, you're probably not going to learn it this way. As a matter of fact, the way I was taught in high school was different than literally every other student I've ever seen take calculus. But I like my way better, so I teach it that way. I think it's easier to remember. What you're probably going to learn is you're probably going to learn instead of u and v, instead of u and v, you're going to call it f of x and g prime of x. They're basically both the same thing. They're functions. You got f prime of x and g prime of x, same thing. The reason why I don't like this method, and you'll probably learn it this method at some point, and do what your teacher says, but the reason why this way is stupid and it's not the best way, in my opinion, is because what if you have the function f of x equals x over cosine x? Then this is going to get confusing, right? Because you're saying your numerator is f of x and your denominator is g of x, but the function was already called f of x. You're like double dipping with the variables. That's horrible. I don't know why they teach it this way. The other reason this is horrible is because what if your function isn't even of x? What if I have f of t equals t over cosine t, and now you're going to call the numerator f of x, and you're going to call the denominator g of x anyway? Yes, technically you can call it f of t and g of t, but your teacher's not going to teach it that way. I almost guarantee you. It makes no sense. I hate it. But whatever. I'm not a teacher. I'm a tutor. So that's why I get paid to make things make sense. And your teacher basically gets paid to get yelled at by a bunch of underage Neanderthals, which is you guys. So be more respectful to your teachers. They deserve it. Even if they don't deserve it, be nice. Why would you be mean? Don't be mean. That's horrible. 2 more rules to go. The next rule is multiplication by a constant. This is the easiest rule in the world. Basically, if you have any of the rules I said above and you have a constant in front of it, remember a constant is just like a number, then all you need to do is say the answer of the derivative times the coefficient or constant. So when I have f of x equals 5 secant x, and I want to take the derivative of secant x, I know f prime of x is secant x tangent x, and then I just need to put the 5 in front and you're done the derivative. Notice this is not a product rule. Why not? A product rule has an x there. So in other words, if this was 5x times secant x, that's a product rule. That's when you got to do the u and v and the u prime and v prime. But when I just have a coefficient, just the number 5, then just put the 5 out in front. It's the easiest thing in the world. Don't forget that. And then the last rule we have is the sum rule. The sum rule is basically whenever you add 2 of the rules we mentioned earlier, you literally just do them separately. Take derivatives separately. That's all you got to do. So when I look at 2x to the fourth plus 3 tangent x, this is actually a pretty complicated example because we haven't talked about power rule in a while. And 2x to the fourth is a power rule. Let's see what we do. So first the 2 just goes out in front because I said so, because of the rule number 7, the constant, multiplication by a constant. Now, the power rule says that 4 in the exponent needs to go out in front. That means I will be doing 2 times 4, which is obviously 8, but I'm not writing that yet. I'm just saying pull the 4 out in front, and then times x to the 4 minus 1 power, which is 3. And so your derivative will be 8x cubed, like that. Then for the plus 3 tangent x, that's going to be plus 3. And then derivative of tangent x is secant squared x. And that's what I'm going to be putting right there. Again, you have to memorize the derivative of tangent. It's secant squared x. And it's positive, which is nice. Any questions on any of the 8 rules I just said? No? Okay, great. Then here on the next page, I have a summary of all the rules I just said. You can use this as a little cheat sheet. And for the rest of the time today, we are just going to be going over practice problems. And believe me, this is going to help, like taking your medicine. So for number 1, we have the derivative of 10x cubed. What rule is this? This is mainly the power rule. Yes, there is multiplication by a constant as well, but I'm just going to say the power rule because that's the main rule. Now, what do? We're going to say f prime of x equals, the 10 is a coefficient, so just write it first. Now, what's the derivative of x cubed? Well, first pull the 3 out in front, so times 3, and then times x to the 3 minus 1 power, because that's the power rule. 3 minus 1 is 2, so the answer is 30x squared. Any questions there? Okay, good. Number 2, another easy one. 3x plus 5. You'll notice this is written in the form y equals mx plus b, and you know the slope is 3. But what I want you to say today, using rules of calculus, I want you to say the derivative of 3x, that's the coefficient rule. Remember, that's the one that just says if you have something in front of x, then the number is the derivative. In other words, 3 is the derivative. And then plus the derivative of 5, that is the constant rule. And the constant rule just says the derivative is 0. So f prime of x is 3, and we're done. Any questions there? Okay, good. We're moving on. The next one, number 3, y equals negative 1 over x. Looks like we've got a quotient rule, right? Wrong. Don't use quotient rule here. Don't use quotient rule unless x is in both the numerator and the denominator. I'll give you a second to write that down. But basically what I'm saying here is that there's no x in the numerator, so there's something better that we can do without the quotient rule. What we can do is we can say this is negative 1 times x to the negative first power, because whenever you have an x in the denominator, you can bring it back up to the numerator by making it a negative power. This is still part of the power rule. Keep in mind, this is not the answer to our question. This is just rewriting it. This is how we rewrite it to make it easier. Now we can use the power rule. So basically what I'm saying is y equals negative x to the negative 1, which means y prime or dy dx, if you want to call it that, I don't care. Y prime or dy dx equals negative times negative 1, because that's the power, times x to the negative 1 minus 1 power, which is negative 2. So that means the answer is double negative right here means positive 1, x to the negative 2 power. That's one correct answer. The other correct answer is 1 over x squared. I don't care which one you write. Personally, I prefer the right one because I don't like negative exponents, but technically both are right, so I really don't care. Any questions on that one? Okay, and then one more to go on this page. It's number 4, y equals root 2x. I'm sorry, 2 root x. Remember, you can rewrite this as 2 times x to the 1/2 power, because square roots need to be rewritten as a fractional exponent as 1/2. We need to memorize this. So now, this just becomes a power rule again with a multiplication by a constant. So I'm going to say y prime equals 2, just pull the 2 out in front, times, pull the 1/2 down, multiply it, and then times x to the 1/2 minus 1 power. Remember, 1/2 minus 1, we did this earlier. It's negative 1/2. Looks like the 2 times 1/2 will cancel with itself. So the answer is x to the negative 1/2. That's one correct answer. The other way you can rewrite this, negative 1/2 power is a square root because of the 1/2, and in the denominator because of the negative sign. What I'm saying is x to the negative 1/2 looks like this, 1 over root x. That's what it looks like. Any questions? Okay, good. Now let's continue with number 5. Number 5 looks like a long and complicated one. As it turns out, this is one of the easier derivatives you're going to see this year, number 5. So if I'm saying the derivative, notice it's a lot of addition sum rules together. We're just going to do 4 power rules in a row, basically. So for the first power rule, we got 3x cubed. So f prime of x equals the first 3 is just the coefficient. It's that 3 right there in front. Then times the 3 from the exponent. Bring the exponent down. And then you've got x to the 3 minus 1 power, so that's squared. Plus, now I have to worry about the 2x squared, okay? So 2x squared is first I write the 2 from that 2 in front, and then times bring the 2 down from the exponent, so another 2 right there, times x to the 2 minus 1 power, that is x to the first power. Technically, I don't have to write that 1 because it's a 1. You don't have to write x to the first, but I will just for example purposes. Next is plus the derivative of 5x. The derivative of 5x, that's just a coefficient rule. Derivative of 5x is 5. And then plus the derivative of 1, so plus 0. Derivative of 1 is 0. So simplifying my final answer, 3 times 3 is 9, 9x squared, plus 2 times 2 is 4, 4x, plus 5, and there's your derivative. Again, if you were to do this the old-fashioned way with the limit definition of derivative, you would be spending an hour on one problem. Not fun. Not even for me, and I like that. So that's it for number 5. Next up is number 6. I'm going to write it on a different page because I need more room. It's 2x over x squared plus 1, and it's g of x. So what rule is this? This is the quotient rule because we have division and because we have x in both the numerator and the denominator. So what that means, I'm going to say u, my u is 2x, my numerator. V is my denominator, x squared plus 1. Now before I plug it in the formula, I'm going to take the derivative of u and v, which means u prime, the derivative of u, is 2. Derivative of 2x is just 2 because the coefficient rule. And then v prime, derivative of x squared, that's going to be bring the exponent down, so 2 times x to the 2 minus 1 power, so x to the first. And there we go. We have everything we need for the formula. Now remember the formula for the derivative of quotient rule is low d high minus high d low over bottom squared, and off we go. If you don't like the song, you can just memorize the formula flat out. I would say the smartest kid during a summer lesson I ever had was someone by the name of Vivian. Not going to say her last name for protection purposes, but what Vivian did was she literally wrote down this formula 20 times in her notebook and then she memorized it. And that is what I would recommend you do because honestly, that is a smart way to memorize things, just writing it over and over again. So let's just plug in. V was the x squared plus 1. U prime is just 2. Minus u, which was 2x, times v prime, which is 2x to the first, which I don't even have to write, 2x to the first. And then divided by v squared. Remember, v was our x squared plus 1, and that whole thing is squared. And remember, we're going to simplify the numerator, and we're not going to touch the denominator. The reason why is because the numerator can be simplified pretty easily. In the denominator, I mean, don't FOIL it. That's just going to make it worse. This looks pretty good, actually, in the denominator, right? So I'm going to distribute in the numerator. X squared times 2 is 2x squared, plus 1 times 2 is plus 2. And then minus 2x times 2x, that is 4x squared, because I have to multiply the 2's together and then the x's together separately. Divide that by x squared plus 1 quantity squared. We're almost done. We just have to combine the like terms, 2x squared and negative 4x squared, to give us negative 2x squared plus 2 over x squared plus 1 quantity squared. And there's our answer. Any questions on that one? This is the hardest one we've seen tonight. Hopefully you had room to write it. Okay, no questions? Moving on. How many more do we have left? 7, 8, 9, 10, 11, 12. Just 6 more to go. And believe me, this is great practice. So you're lucky if you're watching this. Number 7, y equals x to the 3 halves plus x to the 5 fourths. We have not seen this one yet, this kind of multiplication and power rules, but this will be a power rule, okay? This is not some new rule we haven't discovered yet, still a power rule. And what I'm going to say is, I'm going to write dy dx this time because we have y, and I want to mix it up a little. I could have also written y prime if I wanted to, but I don't care. So for x to the 3 halves, again, 3 halves is the exponent, pull it out in front, times x to the, what is 3 halves minus 1? Remember, 3 halves minus 1 is the same thing as minus 2 halves. Looks like it's going to be x to the 1/2 power. So that's the first part. Second part, x to the 5 fourths. Well, that's going to be plus 5 fourths x to the 5 fourths minus 1 power. That's going to be 5 fourths minus 4 fourths, which is just 1/4 power. And honestly, this really can't be simplified any more than this. I am happy with it. I'm going to keep it like this. Any questions? No? Okay, good. Next, number 8. Number 8 is a tricky one. We've got h of x equals secant x times secant x. So if you remember the derivative of secant x from that table, we said the derivative of just one secant x is secant x times tangent x. So that means h prime of x, the derivative, is going to be secant x tangent x times another secant x tangent x. Does anyone have any questions about this one? I have a question. Do you remember what I said earlier? Here's a quiz question for you guys. What did I say was the hardest rule to remember out of all 8 rules we did?
The quotient rule?
I did not say the
Or
quotient rule.
oh, sorry, the what's it? The trig one?
No, even that's just memorization. The hardest one to
Product?
remember is the product rule, and the reason why is because I said you will not even know when to use the product rule. This is a perfect example of that. This is wrong, by the way. This is wrong. And the reason why I did this to trick you is because number one, I'm a jerk. And even two, more importantly, is because this is the number one mistake I see my students make in all of calculus. They will literally miss the product rule all year. I'll get upset with them, and for the right reason, because I will do the same thing I'm doing with you right now. I'm going to teach them the product rule. I'm going to mess up on purpose, and then they still mess up 5 more times until they actually remember. And you will do the exact same thing, I guarantee you. I did the same thing when I was in your shoes, so I get it. It doesn't make it okay. And so every time you make that mistake, I will tell you, and I will not yell at you because I don't have a voice anymore, but I encourage you highly to remember the product rule. So what does the product rule mean then? I'm going to erase what I said earlier. Basically what the product rule means is I need to say the first secant x is my u, the second secant x is my v. Now, u prime is secant x tangent x, and v prime is also secant x tangent x. And you need to remember the formula. It's uv prime plus vu prime. And remember, the order doesn't matter. You can change that up. So now the derivative of this is u, which is secant x, times v prime, which is secant x tangent x, plus v, which was secant x, times u prime, which was secant x tangent x. You'll notice this will simplify because the secants can multiply together. You'll get secant squared x times tangent x plus another secant squared x times tangent x, because that's the exact same thing. Again, why is it secant squared? Because you've got two secants multiplied together. That makes secant squared. And then the final answer you could say, and I know I ran out of room a while ago, but we've got 2 secant squared x times tangent x because they are like terms. They are the exact same thing. You can add them together, and now you've got 2 secant squared x tangent x, and that's the best answer. Any questions on that one? No? Okay. So that was a fun one. I was looking forward to having that whole rant about this problem all day. So thank you for giving the wrong answer. Well, technically I gave the wrong answer, but still, you were complicit, and that's the problem. Anyways, number 9. If you don't know the rule for number 9, I want to slap you because it's the same rule we just did. It's the product rule again. This is our chance to redeem ourselves, right? So the first thing I'm going to say is x to the fourth is my u. U is x to the fourth. My v is cotangent x. That means u prime is 4x cubed. Hopefully we're getting at the better at the power rule, so I don't need to explain why that is. And v prime, the derivative of cotangent, I don't expect you to know today, but it is negative cosecant squared x. Now again for the product rule, and it's easy to mix those up in the names because they sound so similar. Power rule, product rule, they both sound very similar. Make sure you don't mix them up. But u times v prime, so x to the fourth times negative cosecant squared x, and then plus v times u prime, cotangent x times 4x cubed. And honestly, this really can't simplify much more than this. I'm okay with leaving this as our final answer. Any questions? Okay, good. Next is number 10. Again, I'm going to write it on a separate sheet of paper. F of x equals sine x over cosine x. This is one of my favorites. So basically, hopefully you realize this is definitely going to be a quotient rule because we've got x in both the numerator and the denominator. Now what's funny is the quotient rule is technically a harder formula than the product rule for obvious reasons. It's got more going on. You've got u, v prime. Did I say it backwards? I did say it backwards. V u prime minus u v prime over v squared. That's the quotient rule. Easy to mess that up. But what I've noticed is since students know it's harder, they spend more time with the quotient rule than the product rule. And so my students usually know the quotient rule pretty well. And they usually forget the product rule. So make sure you know all the rules, and then you don't have to worry about anything. So anyways, the u is going to be sine x. The v is going to be cosine x, your denominator. That means u prime, the derivative, is cosine x, and v prime, the derivative, is negative sine x. Again, I have them all memorized. You should too by next week. So next, you just plug in the formula. It's going to be cosine x times u prime, which is another cosine x, minus u, which is sine x, times v prime, which is another, actually that's negative sine x, and then divided by v squared, so that's cosine squared x. Remember, that's the better way to write cosine x squared. And again, we're going to try and simplify this as much as possible. So for instance, cosine times cosine is cosine squared x. Double negative here on the signs means you get plus sine squared x divided by cosine squared x. Now what's funny is, does anyone see something special in the numerator?
Yeah, it's a trig identity. Can't you
It
just say
is,
it's 1?
yes, it's a trig identity and it's equal to 1. This right here, cosine squared plus sine squared, that just equals 1. Looks like our final answer is 1 over cosine squared x. And if you're good with your trig identities, you'll also know that this is secant squared x. And there's the best answer. This answer is also good, but let me tell you why this is the best answer. And you're gonna love me now. Basically, what was the original problem again? Let me write it down again. Sine x over cosine x. Can anyone think of a way I could have avoided the quotient rule and done this in like 5
That
seconds?
was tangent x.
Yeah, that's tangent. You can just say sine over cosine's tangent, and if you have the formulas memorized, derivative of tangent is secant squared x. Done. No quotient rule. And I remember our teacher showed this to us again in calculus, and we were so excited to try the quotient rule that we completely missed the obvious, which is you can simplify your problem before you take the derivative. Word to the wise, always try and simplify first. 90% of the time you can't simplify it, but 10% of the time you can simplify it, and that 10% is what's going to separate the people who are really good from the people who are just good. By the way, I was not really good until the end of calculus, so don't expect to be as good as me until, well, you've been doing this for 8 years like me. Anyways, number 11, it's a good one. It's f of x equals the cube root of x to the fifth. In the same vein as rewriting problems, like we said for number 10, we definitely want to rewrite this. Now, one thing you ought to know about what we have here, whenever you have a cube root, remember that's like the 1/3 power. So really what you have here is x to the fifth raised to the 1/3 power. This is not the derivative, this is still the original function, I'm just writing it slightly differently. Now, when I have a power to a power in algebra, you need to multiply the fractions together. In other words, I have x to the fifth times 1/3. That is x to the 5/3 power. We have still not taken the derivative yet. This is still the original function, but this is now a power rule, not a product rule, power rule. Which means I pull, now I write the notation for f prime of x. The derivative is pull the 5/3 out in front times x to what's 5/3 minus 1. So 5/3 minus really 3/3 is 2/3. By the way, you'll be amazed at how many students forget this. It blows my mind every time. I don't know how. But it's 2/3 power, and there's our answer. You do not need to write it back in the form of the original question. In other words, you do not need to write this as the cube root of x squared. You do not need to write it like that. That's not necessary. This is absolutely fine. Any questions there? Okay. And then the last one we have for today is number 12. It is by far the hardest problem that you'll have ever seen in your calculus careers, at least for week 3. It is y equals x squared times tangent x divided by x to the fourth plus x squared minus 1. And you see I have a warning here. It's product rule and quotient rule. And the reason why I put this warning here is because basically whenever you have a product rule and a quotient rule, you can technically use both in the same problem. Technically, this is true, but basically what this means is you want to use a little strategy called logarithmic differentiation. Now, the word logarithmic means you're going to use a log to solve this problem, and the differentiation word, differentiation is just a fancy word for derivative. That means the exact same thing as derivative. It's worth knowing the vocab in this class. Differentiation just means derivative. And honestly, logarithmic differentiation is out of the scope of this 8-week course. In other words, you do not learn this until towards the end of calculus. What I'm trying to say is we're skipping number 12 because it's too hard. You're happy. I'm happy because I get to go home early. And this logarithmic differentiation thing, I mean, you're not going to see it until towards the end of the year, so I'm not going to explain it. But it's a way you solve really, really, really hard derivatives. Now for next week, we're going to be covering chain rule, which is going to be harder than every rule we've said so far today, and you should look forward to that. Your homework this week is obvious, problem set 3. I'll show it to you later. I'm going to send an email with all the problem sets and everything like that. But the one thing I do want to say is that really, and this is the most important thing, you need, starting from this week onward, if you fall behind, if you don't do the homework, if you don't know what you're doing, if you don't remember the trig derivatives, if you don't remember the power rule, it's not even worth attending the rest of these lessons because I'm going to be using this stuff assuming you're good at this stuff in week 3. Okay? So it's super, super important that you have this week down. This is the most important week. I know it's going to be a lot of homework, probably 2 to 3 hours, honestly, if you really want to get to the level you need to. But if you spend 2 to 3 hours this week learning this stuff, you are going to be in such good shape for the rest of this class that you shouldn't have to worry about it. Okay? So thank you all for watching. I hope you have a great rest of your night. Take care, and bye-bye.